Hello, Vadym. How are you?
Fine, ready to present, as always.
It's nice to have you back. You were with us last year, and today we have a pleasure to have you also, and especially because you're opening today's event, and yeah, you are the first speaker of today's live stream, and it's pretty nice, and especially because it's Java related event, and Spring is the most popular framework as you mentioned, and also AWS most popular provider. How it could be another topic to kick off a Java related event, right? So
Yeah.
looking forward for your presentation, and we can jump straight to it.
Okay. Then thank you very much. And добрий день. Я повинен поставити мету, може, наступний раз на українському доклад робити, але 25 років у Німеччині це трошки складно. So I just said that I would like to do this type of talk in English next time. But yeah, too long in Germany, so that's why I just would like to stick to English or to German. So yeah, thanks once again for inviting me. So you see me sharing now, yeah?
Yeah, perfect.
So thanks for interrupting. If you see that the one screen is a long time not changing, tell me because I will switch quite frequently.
Sure.
So yeah, you didn't miss anything in terms of slides. Maybe, yeah, so this is this demo application that I will be using, the product API, so for the application for creating and retrieving the products. And the product API is managed API gateway on AWS. And for simplicity, I only have two Lambda functions for creating a new product and where the business logic resides with Java as a programming language, and then another Lambda function to retrieve the product by ID. I will be using completely serverless DynamoDB table. It requires a bit of knowledge how NoSQL database works, but not too much. You can replace it. I will say something about it. If I will be using Java, this is how the Lambda function needs to be written, which does retrieve the product by ID. This is basically I implement request handler interface from AWS SDK for Java, and it implements handle request method. Because I use API gateway as a trigger, public facing interface, then the type of event is API gateway proxy request event, basically, and from which I get the ID, and then I'm asking the DAO product DynamoDB DAO just to fetch this ID. So this is nothing wrong if you will simply say, I can use Spring and simply inject product DAO. I don't use any services here, just simply inject product DAO. And that's fine, kind of. But what I would like to be focused on in this talk is more portable solutions, basically reusing as much as possible, not everything, but basically, if it's possible, reuse even Spring Boot controllers, but portable in the sense that you can switch basically services on AWS cloud, because DynamoDB locks you in, but if you see it's not, the performance is not that you would like, you can switch to containers on AWS or pure EC2 servers. That will be possible. Of course, you will need to adjust dependency management infrastructure as code part, because it's different services require different logic, but the business logic will be easier to port. Once again, DynamoDB locks you in here. But you can try other databases. You can try manage Postgres and all that stuff. There are lots of choices on AWS. Even now, Aurora DSQL was released several weeks ago. Also, Postgres managed database. So you have options, but you will need to remeasure performance, because basically DynamoDB, pure AWS serverless one, gives you the best performance. I will also reference my other articles where I explore these ways. But there are other trade-offs like connection management with traditional relational databases. So what will be our agenda here? We will explore several approaches just to use to make that solution portable. These are all open source projects. Two of them are maintained by AWS, like AWS Serverless Java Container and AWS Lambda Web Adapter. And we will be also using Spring Cloud Function, which is independent framework, and it has different adapters like also AWS adapter. We will very briefly look into you can deploy also containers on AWS Lambda, so you can containerize your application. But we'll also measure and then see the techniques that I also presented last time. We will use it there, AWS SnapStart and GraalVM native image, and just see a bit of trade-offs, what we will see there. So you will have on all slides, you will have a link to GitHub repository, so you can simply clone the code and run it on your own. So first of all, I will present a piece of business logic that is common for all approaches I will take, so just not to show it with each of this framework. This is basically main entry point to your application. This is the class annotated with Spring Boot application, with the main methods just completely reused. The same is true. I have, for simplicity, very simple record product that I will be store or retrieve, only ID, name, and price is a big decimal. And this is the repository part, how to implement DAO with DynamoDB. It requires a bit of knowledge and usage of AWS SDK and DynamoDB part, but basically you see below, this is the put product. Just to put the product, this JSON into DynamoDB. And of course, I construct this DynamoDB client just to talk to DynamoDB database. And this is the part to retrieve the product by ID. Just I construct, get item request, and then I get item response, and then I can convert it to the product. So it requires a bit of knowledge, but let's abstract it with just simple repository, basically. So now let's start with the specific part. First, let's look into AWS Serverless Java Container. This is a framework which provides container just to make it easier to run Java applications written in different frameworks. There is even struts for older people like me, but there is also Spring Boot 2 and a 3 version, and also others. So what these containers provide, it's adapter logic. All frameworks will be some kind of adapters to minimize changes. So incoming requests are basically, events are translated to Jakarta servlet specification, so that the frameworks can work as before. And what mean? So first of all, you need some dependencies. I use POM, but you can use whatever it is. You basically have this AWS Serverless Java Container Spring Boot 3 dependency, which provides this container for Spring Boot 3. Important is to exclude dependency to Tomcat. We are using managed API gateway, so this dependency is just several megabytes, and we don't need this, so simply exclude that. And basically, we can reuse controllers. So you see here product controller, which is typical REST controller from the Spring Boot, and we have here DynamoDB auto-wired, and we have two methods, create product and get product, and we use request mapping annotations and all that stuff that we simply use. So now how this stuff is resolved, how the framework knows that this controller method needs to be invoked. This is the mapping in the infrastructure as a code. Fortunately, we need that. And this is, I use here AWS SAM, but you can use CloudFormation, whatever you want. You see here, this as an example, only get product by ID function. You see here below, there is a path product / ID as a dynamic and method get, and it maps exactly to request mapping annotation of the get product by ID method. Yeah, so there will be controllers discovered, and then via this mapping, then this framework would know, okay, there is no Lambda function, it's hidden kind of, but there is a controller, and this method needs to be used just for mapping. Of course, you need to define some kind of handler Lambda function, because this is how AWS works, but this serverless Java container provides this proxy with the very long name, Spring Delegating Lambda Container Handler, which comes with the framework. You simply put there, and this container handler will simply resolve the controller and method for you. That's basically it. So you can completely reuse your business logic. There is another framework, AWS Lambda Web Adapter, managed also by AWS people. It works a bit differently. It's written in Rust and supports the frameworks, not only Java frameworks. You see here Express, Next.js, ASP.NET. So a bit of different type of framework and for different goals. And you can also not only use it in serverless, but also on other types of services. And it doesn't only support HTTP-based triggers, but also non-HTTP. If you are familiar with AWS, it can be simple query service, simple notification service, so all other triggers. For us, it's for this type of talk, it's not relevant. So it's the main thing, it supports Amazon API gateway as well. It's packaged a bit different. There are many ways to package it. I will package it as a so-called Lambda layer. So you can attach the Lambda layer to each Lambda function. I will show you. But basically, the controller looks completely the same as the example before. Exactly, no dependency to AWS. Infrastructure as a code mapping works exactly as before. Also, no dependency to any to AWS framework. But here you see this Lambda function get product by ID. You need to see here layers. This is the layers provided by AWS. Just to simply copy more or less this line. The last you see that's the version 23. You can look up if there is a more recent version of it, and you see the handler. There is no Lambda function as a handler. You see run bash script. And this is very basic script that you can provide to your application, which starts Spring Boot application. Yeah, you see here execute Java class path, and this is application class is my class where the Spring Boot annotation is placed. So no Lambda function here is used, but a simple starting as you will start on Spring Boot application on containers, basically. The thing is, it relies on Tomcat. You need to have Tomcat as a dependency. Yeah, it's another magic happening with the adapter, but basically it's how it works. And that's basically it. So very similar to the logic before, but Lambda layer instead of Lambda function. Probably you are familiar with the Spring Cloud Function framework itself, because it's maintained basically by Spring, or just Broadcom, the company behind it. And the goal of this framework itself is to promote the implementation of the business logic via functions. And under functions, what we mean is Java 8 functional interface with the apply method. That's the only method. So you can simply write business logic and then promote it as a functions. And it can be even JMS message, or it can be AWS Lambda function, it can be Azure function. So there are kind of adapters that can be put behind. Yeah, and that allows you also kind of decouple your business logic from specific target like AWS, but it doesn't work 100%. We will look now into the example. So yeah, you see here the path request adapter will be converted, the JSON coming from Lambda function once again in this HTTP servlet request. Then it will invoke the Spring dispatcher servlet, and then the business logic will be executed, and then it comes back as a response. So basically, very similar how it works for the first framework that I presented you. So AWS Serverless Java container, simply just converting the things coming from API gateway through Lambda then to this framework specific logic, and then sending a response back, so that basically you don't need to do too much. Dependency, you need to declare dependency. You see here Spring Cloud Function, adapter AWS. There is also adapter Azure, for example. And you see here we need Spring Cloud Function web just to hook into this API gateway request. Once again, you don't need Tomcat, so exclude it. It just doesn't rely on it, and you save on some dependencies. And now it's a bit differently how it's mapped. So first of all, this is the infrastructure as a code part. You see the handler. This is once again function invoker, comes with this Spring function AWS adapter. Simply copy this. This is what the frameworks gives you. You need two variables, environment variables. First, the main class with the Spring Boot annotation. This is our application class. And now we need kind of mapping. Let's first see the business logic. Once again, this is get product by ID handler method, and you see we implement function interface, Java 8 function interface with the apply method. Unfortunately, I have this one dependency to AWS SDK, this ABI gateway proxy request event. Yeah, this comes what you will be using in normal Lambda function. Unfortunately, I cannot inject this. It's not a web application. There is no controller. I cannot use request mapping annotation because I only need ID here. I only need request event, get path parameters, and get product ID. But unfortunately, this small dependency is there. That's why the portability, for example, to another cloud provider like Azure requires here to replace or provide abstractions and then to replace stuff. But basically, this is the Lambda function which implements function interface. Now, how is mapped? Once again, let's come back. You see this variable Spring Cloud function definition. And this gives the bin name, which will be resolving to the business logic. And this bin name, get product by ID handler, is exactly the bin name of this class. Because by default, the Spring bin name is the class name, the first letter converted to lowercase. You can, of course, put in component another Spring bin name and then map it to this, but this is the default conversion. That's why that Lambda function knows that this function interface kind of corresponds to this. I will not be focusing. You can package all three possibilities also as a Docker image and deploy it. The thing is, it provides the worst performance, and there are no optimization techniques. That's why I will jump over it. There are, of course, certain advantages with the Docker. You can use recent Java version, but basically I experienced the worst performance. I could not basically improve it. So now let's come to, once again, in case you're not familiar, Lambda, where you place the business logic like get product by ID that we saw, create product, is a function as a service. It's completely different to all others like platform as a service, container as a service, EAS, and all that stuff. So basically one environment, one execution environment is only capable of executing one request at a time. And then the environment comes back to the pool, similar as a connection to the data source pool. And that's why it's different. It's not horizontally scaling the environments, the complete environment. And when we need to scale it, then we have less warm environments than the request. For example, we have 5 execution environments in the pool. Now we have 10 requests. We can 10 requests in parallel. We can reuse 5, but we need 5 new ones. And of course, if we redeploy the Lambda function, then the new environment needs to be started. The older needs to be recycled because they contain the old version of the code, of the business logic, and so on. And sometimes AWS also releases the environments to patch the stuff because for security reasons. So what happens for the first time? Let's imagine that's a completely new Lambda function. What will happen if we deploy that? So first of all, AWS has its Firecracker VM. This kind of hypervisor is this execution environment which contains this fully isolated environment. We select Java as a programming language. That's why AWS Lambda will start Java runtime. And of course, then Java runtime will need to load the stuff. So first of all, the function code to be downloaded. It's deployed on S3. So the execution environment needs to download it. The class needs to be loaded that are required in the beginning. Java uses lazy loading, so certain things will be loaded only when we first need that. But of course, the static initializer block of the Lambda function needs to be executed, and all dependencies reachable from the static initializer block. And of course, if we use Spring Boot, then runtime dependency injection might kick in just in time compilation. This is all parts which is so-called cold start. So download your code, start the execution environment, and this execute init code. These are parts of the so-called cold start or startup phase. And the last part is Lambda invokes the handler method, where the business logic resides, where only kind of get product by ID. This is the warm execution. And if the container, there is a warm container, only the last step will be executed, this warm start. If there is no container, then all 4 steps will be executed. The first 3 of them are cold starts. So now let's measure that stuff. Just simply see. I used 3.4 Spring version, Spring Boot version. So not the recent 3.5. I gave Lambda 1 GB of memory. It's a good starting point and uses the default x86 architecture. There are others. I will briefly mention this. I use tiered compilation disabled, like tiered stop at level 1. For short-living Lambda function, it's very good choice. And I run my experiment for 1 hour. I just put a bit stress on this get product by ID Lambda function, like executing it hundreds, even thousands time in parallel. Then I kind of stopped the execution so that the container is gone. Then I restarted this, and this took kind of 1 hour for experiments. So you see, I had approximately 100,000 executions, warm starts, and only 100 cold starts within this hour. So you see the cold starts are quite rare, only 0.1%, but it's my type of workload. Your type of workload might be different. I only have one Lambda function you can use on the on your page many Lambda functions, and you need all the results. So if one will run into the cold starts, then the whole performance may suffer. So this is only for simplicity. Normal pattern will be several, 1-3% maybe of the cold starts. Yeah, I will present you the results. You will see these images, the cold images for the cold starts, and you see here kind of fire. It's for the warm starts. So without any optimization. So what we see for all three frameworks, and I also show you here Docker image for AWS Serverless Java container. This is the cold starts in milliseconds, and I have percentiles like P90 mean in 90% of the cases. This is the yellow line. You have this type of result. So what you see if you look into the yellow line, AWS Serverless Java container 7 seconds cold start. Yeah, AWS Lambda Web Adapter nearly 5 seconds. And Spring Cloud Function AWS Adapter 5 seconds. What does it mean? Quite huge cold starts. Not everybody will wait like on the login function if you are not able to optimize it for 5 seconds, 7 seconds, and all that stuff. This is what I presented to you last year. The last column is the cold starts without using Spring. So pure Java function. As less dependencies as possible. You see 3.2 seconds, the yellow line, the last column. So you see the using Spring Boot adds 2 seconds, depending on the framework, even 4 seconds on the cold start. It's kind of a problem. Yeah, so it's this dynamic type nature of Spring Boot adds on that. The warm starts are indeed more or less okay. You see here P99, 20 milliseconds. That's fine. Java is a very quick programming language, and even adding Spring Boot, and I show you now the last column is without Spring Boot. You see that warm starts by adding Spring Boot a bit bigger, several milliseconds, but it just doesn't matter. So the warm starts are basically not a problem. So that's why we will basically focus on how to optimize the cold starts. I will jump over this. So let's start with the AWS own offering Lambda SnapStart, which I also presented last time. So what is that? Logically, Lambda SnapStart is the possibility, the offering to improve startup performances, startup cold starts for latency-sensitive application, and it's fully managed. So what does it mean fully managed? Basically, you decide per Lambda function, would you like to have SnapStart or not? You see here in this orange, that's basically true or false. It's one line in the infrastructure as code, just to define it. So I will show you what does it mean, but it's currently available since end of the last year, not only for Java runtimes, but also for Python and Net. So the programming languages that kind of suffer from the cold starts in Python with LLMs, it can be a quite nice solution. So it's not available for Docker container images. That's why we can't optimize it. And for custom runtime, this is the way how we will be shipping GraalVM native image later. So basically what we can do is just to use that for the first 3 frameworks that I introduced and see what will it bring. And I will show. But first of all, how does it work? What is that SnapStart? In case you enable Lambda SnapStart for Lambda function, then the life cycle will be divided in 2 pieces. There will be additional things happening on deployment of the Lambda function and additional things on invocation. And it's very important to understand. So you see on deployment, there will be additional steps. Normally we deploy Lambda function, nothing happens. But here the container will start this Firecracker VM and execute all steps that are cold starts. Yeah, they will not execute your business logic. They cannot because there is no event like give what is the ID to get. But they will simply download S3 code and run all the static initializer block, and then they will create a snapshot of your running application. The snapshot is this micro VM Firecracker micro VM snapshot. The fully snapshot of its operating system is JVM and the state of your application. This will be snapshotted. There are optional hooks. We will be looking into that. And then during the invocation, the snapshot will be restored in case SnapStart is enabled. Of course, there is post hook, and then the function will be invoked, basically. Yeah. So what's the promise? That the restore phase is quicker than the cold start. Otherwise, it doesn't make any sense. And we will be looking whether that's true or not. Probably you hear snapshot and all that stuff. You probably heard about Creo, Crack, and all that stuff. Similar technologies, but Firecracker does it differently. So Crack is based on Creo, just for moving around containers, and Firecracker snapshots the whole running operating system, and Crea snapshots a single process, for example. There are different advantages, disadvantages. It probably deserves the whole talk, but a bit different technologies. It's not the whole thing. You can simply activate SnapStart without writing the business logic, and you will see the results later. I will show all of them, but it's not the end story. We can use so-called priming, pre-initialize stuff that it becomes a part of snapshot, just to have the restoring. And what can be pre-initialized? We can preload as many Java classes that we need. For example, the things that will be only required during the warm start execution, only then they will be for the first time loaded. So it will not be the part of the cold start, but we can preload things by executing faking methods, just by taking advantage of lazy loading. And we can also pre-initialize other stuff. For example, we'll be looking how to pre-initialize communication to DynamoDB. DynamoDB is HTTP-based service, and that's why it's HTTP-based connection. And with that, we have Apache client by default, HTTP client, and we have JSON marshaller. Both can be pre-warmed. For example, I will show you later. And of course, what we can also pre-initialize is this adapter logic of the framework that I showed you, because there is a resolving logic. Yeah, for example, how to map to the correct method of the controller. This all needs to be resolved for the first time and then cached. And if we can preload that, then we can speed things up. And you will see this a bit hard to understand, but the first question is how we can do this. And now this pre-snapshot hook comes into play. You see this during the deployment phase in this orange block. You see this pre-snapshot hook, which is executed right before the snapshot is created. And we can put as much logic as possible. This hooks uses Crack API, but it's only Crack API. There is no crack behind this. It's simply just to give the possibility to use one API for all types of things. Let's start. I will show you two priming approaches. The first one is prime DynamoDB request. So what we can do, I showed you the logic how to talk to DynamoDB. First, you see we initiate DynamoDB client, and then with that client say get item and give then ID of the product. So in the first line, if we initiate DynamoDB client, then there is Apache client by default. We can set another one, but by default, it will be Apache HTTP client. And it's designed more for the long-lived application. And that's why if we first initialize HTTP Apache client, there are several hundred milliseconds initialization. There are lots of singletons and all that stuff. So if we can pre-initialize that, it will be good. The second thing, if we talk to NoSQL DynamoDB, then there is a conversion from Java to JSON or back, depending whether you're reading or writing, or conversion, marshalling, unmarshalling, serializing, deserializing. Default one is Jackson. AWS SDK talking to Dynamo uses Jackson. And if you simply open now your, whatever you use, Eclipse, IntelliJ, and simply invoke new object mapper, which is initialization of Jackson Marsh. Now you will measure, depending on the power of your computer, 300, 400, 500 milliseconds for the first execution. If you copy this line and do this once again, there will be 1 millisecond, because a lot of singletons are involved. If we can pre-initialize that, we can also speed up things. So how to do this? Basically, it's very simple. So first of all, we implement resource interface. This is the Crack API. And it gives you two methods, before checkpoint and after restore. But first of all, in the constructor, we need to copy this logic core, get global context, register this, to register this class as a Crack resource, basically copy this line. And after restore, I don't use it too much. This is after the snapshot is restored, but in the before checkpoint, the business logic be executed before snapshot is taken. And as I already have product DAO get product method, I simply faking the execution. I just would like to have the product by ID 0. I'm not interested is this product in the database or not. With that, HTTP client will be pre-initialized and Jackson Marshaller will be pre-initialized, and a lot of classes will be loaded just to get to invoke this get item on the DynamoDB path. And this is what I would like to achieve. Pre-initialize those two things and invoke and preload as much classes as possible. I'm not even interested in the results. This is kind of priming of DynamoDB invocation. I prime that. There is more complex type of priming that I discovered. I call it API Gateway Request Priming. And basically, if you know how this works, in API gateway sends a bunch of JSON to Lambda function, and then Lambda function comes kind of from the framework, yeah, like Spring Cloud function. They provide this function invoker, and then it will be translated into, for example, in this case, Spring Cloud function adapter type of logic. So this works like this. API gateway receives this type of JSON, and then it calls Lambda, and then this Lambda will simply invoke this Spring Cloud function or AWS Java serverless container stuff. The question is, can I fake that invocation? Basically, can I construct API gateway proxy request event and go through all the steps from the mapping from API gateway request to Lambda and then to the specific framework? And it turns out it's possible for AWS Serverless Java Container and Spring framework just to adapt to write this kind of priming. It works like this. Once again, this is the Lambda function with Spring Cloud function. I implement resource interface. I register it as a crack resource, and what I do here, I use the APIs that are any dependencies are there to construct this API gateway request event. I simply set HTTP method get as a parameters ID, like product ID, and set this is the path products ID, so that this can be mapped to the function interface. This is with that minimal logic, I can construct API gateway request event. And the question is, how can I proxy it? So once again, there is this functions invoker for Spring Cloud function with that framework together. And this provides me exactly this API. So in this before checkpoint, before snapshot is executed, I use this function invoke handle request method, which has input parameter, input stream and output stream. And I construct from this Get API proxy request event that I showed you in the previous slide, the input stream array. And with that, the whole invocation chain from this Lambda function from the framework and to this apply function of the Spring Cloud function framework will be executed. A bunch of stuff. All the mappings will be preloaded, all the classes. It's a bit of additional logic to be written, but it's not too big. Just this type of thing. If you need, for example, create product and you use for example, instead of set path parameters, there is a set body, and you can provide then JSON body. Yeah, this is for the get method, and then you have other HTTP methods. So you can construct all types of events with that. It might sound a bit difficult, but not too much logic and very easy if you figure out that. The similar APIs are for AWS Serverless Java Container, but there are no APIs for AWS Web Adapter. They don't provide this API. I haven't found the way to do this. So this type of priming is only for Java Serverless Container and Spring Cloud function. So now let's see only P90, because otherwise it will be overloaded. Only P90, percentile 90. What does it mean? You see here, I discarded Docker because I cannot optimize. You see AWS Serverless Java Container, AWS Web Adapter, and Spring Cloud function. And you see the red one I already presented. This is without SnapStart. The numbers, the previous numbers. Green ones simply enable SnapStart without any business logic. The yellow ones, SnapStart and DynamoDB request priming, and this, dark red is SnapStart and this last API gateway request priming. So what you see, especially if you look into the yellow one and dark red one, we can go down nearly to 1 second of the call start, and with the Spring Cloud function, even to 800 milliseconds with that. And if you look into the green line, it's only enabling SnapStart without any business logic. We are basically also down to 3.5 or 2 seconds. But especially if you can prime something, and sometimes you cannot prime. If you have like calculator, business logic, A plus B, you will not prime anything. Yeah? So that will not work. But for this time, if you type of application, if you talk via HTTP and all that stuff, there is a lot of priming potential, and especially using this framework like Spring Boot. So you can be really down to 1 second of the cold start, maybe even below. And this is fine. On the right now, you see the pure Java without Spring. There is no API gateway request priming here possible because we don't use this complex stuff. But basically, you see you are near those numbers as if you don't use any Spring Boot. So it's kind of, I would say, acceptable. So warm starts it's not the technology for this. And there is a SnapStart priming guide published by AWS. They show you the ways what you can optimize and what you can't optimize, because it requires a bit of logic, a bit of kind of, I don't know, understanding the things behind. But once you just read through it, it's not very complicated. Once again, AWS released Profiler extension, which is based on open source async profiler. So you can profile your Lambda functions. And this is one of the examples. I could optimize the cold start without using Spring Boot. And there is an article beyond. By using this profiler, I saw the initialization chain and look what can be primed, and just cut the cold start by 20% once again. I need to find out if I can do this for the Spring Boot. It's quite a fresh improvement. But once again, you can see what's happening beyond the scene. So what I showed you, they are the cold starts for all 100 invocations, for the all first 100. There is some magic here, where these snapshots are stored. This is the cache, low latency cache. And this cache is very complicated. It contains of multiple pieces, like operating system pieces, JVM pieces, if you use 21 or 17, but there are also your function code pieces. And if you have a new function, then this cache is empty, yeah? And then it starts to cache your Lambda function pieces, and then it becomes quicker. So this is the property of this cache. It becomes quicker with the time. Of course, sometimes it will not become quicker anymore. But the thing is, the first call starts are slower because this cache is empty, doesn't have your function Lambda function pieces. I recommend this talk by Mike Danilov. He explained how does it work behind the hood and how SnapStart was implemented along the way. It deserves 45 minutes. But basically, if I only show you the call starts, not for the all 100, but only the last 70. So I will drop the first 30, which are kind of a bit slower. Then you see that result. So you see here the pairs, 100, last 70 for each framework. And you see it goes down for the last 70 even much more. So you have here 600 milliseconds, something like this yellow line with the last 70. So what's the morale here? If you don't deploy a Lambda function each 5 minutes, and sometimes you don't deploy it for 1 week, then you will probably experience 1,000, if not 10,000 of call starts. And the first 30, which are slower, just nothing. Yeah, comparing to the rest 9,000, that will be much quicker. And this is kind of it. Yeah, so don't stop by measuring the call start with priming all the stuff after 10, 20 invocations. Measure further. Of course, after 100 requests, maybe call starts that will not be quicker, but the first 20, I would say, are much slower than the all others. So measure until the end. This cache is really a miracle. There are other optimizations. I cannot talk about it because the time is running out. You can use another ARM architecture based on Graviton processor on Lambda. It has other trade-offs. It's cheaper, but in my experience, it's a bit slower. So you need to find the sweet spot, and you need to test with different Java compilation options and different memory settings. By giving less and more memory, you just activate more processing power you need to measure. Depending on your workload, it might be different. And once again, Apache client is a default HTTP client. You can use URL connection one, or AWS provides its own native one, AWS CRT. Yeah, you need just to measure, but with the priming, I saw that the results are quite near to each other for all HTTP clients, because everything is primed, basically. Yeah, there is a pricing. Currently for Java, it says below it's for free, but as it was released for Net and Python, it comes with a pricing. So I would expect maybe someday Java will also has this type of pricing for using SnapStart. Once again, it's for free, but you see here there is a cache and restore dimensions for 2 other programming languages, but it's not too expensive if you will look into the whole pricing. So once again, there are also disadvantages. SnapStart is one of the things. It takes 2.5 minutes to create the snapshot. Yeah, it needs to be secured and stored in all availability zones. But if you deploy multiple Lambda functions, it's happening in parallel. And yeah, there are things that doesn't work. For example, EFS-based system, Amazon EFS, doesn't work with SnapStart, only S3. So there are certain limitations here. If you run into this, that might be not a good solution. I will jump over the comparison of the framework. It's very complicated. I personally would like to stick to AWS Serverless Java Container GraalVM native image can be made from that. For me, it's kind of a sweet spot, but look to what is the trigger for you. Maybe then explore the slide once again. So last words about GraalVM native image. Everybody knows what is that, and especially ahead of time compilation is here important because it's just native image. Yeah, and native image promises less cold start times and less memory because it only contains what's reachable, basically. And Spring Boot 3 and Spring Plus provides official support for compiling Spring Boot applications into the GraalVM native image. So there are annotations. This is so-called Spring IoT, ahead of time processing. So all this annotation needs to, that are normally processed at the runtime, needs to be analyzed at the build time, and the optimized version needs to be generated, which is because native image in reflection, it's another story. You can find examples how to use it in POM XML. They just simply copy the stuff with a process IoT goal. It's not the question, but of course you will run into errors if your application uses reflection. Yeah, and for example, instantiate classes by name. For example, Lambda functions are instantiated by name, or the entity objects and so on. So you need either to fill those stuff, like there is a reflect JSON with all that stuff, or you can use annotations with very long names. You see runtime hits registrar. So identify all those classes. It requires a bit of habit for the first time, but it's not very difficult. But I just spent one day running into class not found exception for this type of application to identify them. Or you can use assisted configuration with GraalVM tracing. Just run the test on the Lambda locally, and it will find all these classes and generate this for you. Yeah, but testing Lambda locally is also another challenge here. So it requires a bit of things. Now this is the cold start with GraalVM. I use 23. You can now use 24. And I used a serverless Java container. You can use also Spring Cloud function and convert that application into GraalVM native image. You see here P90, the yellow 100 milliseconds. Yeah, this is what I measured. And yeah, this is the warm start. They're quick. And this is the comparison of all three frameworks in GraalVM. Like a bit higher cold starts with GraalVM and Spring Boot. For example, if you can use priming and you look into the last 7, yeah, then it's a bit higher. Interestingly enough, as I tested that without Spring Framework, GraalVM produced the best result, but having Spring on top seems to be adding a bit too much, or maybe people can help me optimize it a bit. But basically, we are below 1 second cold start also, if you can prime, which is a good thing, I think. Yeah, and this is once again the comparison. If I don't, on the right side, if I don't use Spring Framework, yeah, you see that the Spring Framework also with the GraalVM, you have 200, 300 milliseconds on the cold start added by having a Spring Boot. Okay, once again, you can give less memory to Lambda function, and GraalVM will produce quite steady results. So you can just give maybe 768 gigabyte of memory, and that will be even quick enough. You need to explore this. Here's the conclusion. GraalVM really powerful, no questions. But of course, other challenges. For example, build custom runtime. It requires also 3 minutes to build this native image for this type of application in my machine. And you need to scale CI/CD. It's your money. You can use managed services that will scale it for you, but just don't forget you manage this process, and snapshot creation on the SnapStart is managed for you. So this is kind of the trade-off, and you need to be careful not to run into this runtime errors and all that stuff. Yeah, and you need to just watch your framework. Is it GraalVM ready? Yeah, is it just, or you will run into runtime problems. The bigger framework, Spring, Micronaut, Quarkus, Helidon, all are battle tested. And below you can also find the open source frameworks and the versions, because sometimes you use also some other open source projects. They have transitive dependencies, so you just need to look. Otherwise, it might be surprised if you upgrade the framework and there is some reflection and just simply stops working and you haven't tested that. What I briefly talked about, you can find in my article series. The link is below on Dev2, with a much better explained, or in kind of I had more time to explain all that stuff. I wrote the article series also how to do that with Quarkus, because it's more natively supported microservices and serverless, and I will do the the micronode also in the future, so that you can compare cold and warm starts. But there are also other properties. Testability, it's not only about performance. To be honest, I'm not focusing here. And word of caution, remeasure. If you simply download my application, you might have different results. For example, the minor version of managed Java runtime, and AWS has its own corrected distribution, might have changed. My patch and it will be better. Yes, you can of course upgrade Spring Boot versions that might change. The SnapStart might improve with time very easily. If AWS improves the technology, there can be a firecracker, micro-VM improvements, and GraalVM improvements. So there are still servers behind Lambda you can run into garbage collection phase. So there might be certain differences. There are still servers behind and all that stuff. But the result direction will be probably the same. Yeah, my personal suggestion, it's easy to start with SnapStart, especially if you can't prime something. It's managed, it's easier. Yeah, if you need, of course, if you can't prime things and every millisecond counts, of course, look into the GraalVM native image. It's mature technology, but requires more on your side. And that's my personal advice. It's I'm not selling something here. I'm not working for AWS and Oracle. And once again, let's look into what will Project Laden bring, because it's comes from Oracle basically, and the goal is to improve start time to peak performance and footprint of Java programs. But they're all these things based on native image and class data sharing, so some type of snapshotting. And for me, if AWS will support this, similar to SnapStart, by managing this type of snapshots for me, then it will bring value. Otherwise, I don't know how to make this snapshot. It's very difficult just to make the snapshot on the first execution and then provide this snapshot for other executions. You need this type of thing that SnapStart do by making the snapshot on the deployment phase once and then providing the snapshots, managed snapshot for invocation by restoring it. So let's wait what the future will bring. And that's basically it, what I wanted to tell you. I hope it wasn't too much, and sorry for problems with sharing. I hope that they have been solved. Thank you very much.
Thank you too, Vadym. No, I guess it's totally enough, and a lot of practical examples and suggestions how to use AWS Lambda and in many use cases. Thank you for all this information and a great presentation. And again, want to highlight that it's great to have you again this year. Yeah, thank you. And yeah, we have a few questions in the chat. So I'll read them one by one.
Yep.
Let's start from the first one from Valentin Boguslavsky. What metrics do you recommend tracking to monitor Lambda function performance?
And basically, you have everything on the CloudWatch side. Yeah, so everything is there kind of by default. You can go to your Lambda function and see all these types like errors. You can have, there are CloudWatch queries for cold and warm start. You can copy them. They're quite different in case for cold start, whether you use SnapStart or not. You see throttling, and you can, of course, we only focus on Lambda performance. Basically, you need to measure end-to-end from API gateway, from the client, starting the request and then the response being basically processed. That's because API gateway has also kind of latency. So this depends on the stuff. But basically, you have everything on the AWS Lambda side without doing anything. Yeah, so everything is there.
Yeah, that's nice. Thank you, Vadym. And next question from Dmitro Malyon. In your opinion, when does it actually make sense to run Spring Boot in AWS Lambda? And when would you recommend using ECS or EC2 instead?
Well, that's a difficult question. So because it's simply broader, when it makes sense to use serverless or not, that's the question. It's very complicated question, and it depends of maybe the knowledge of your people. If you're not familiar with serverless, then it's a different story. If you have more classical system administrators, then they are not very comfortable with Lambda, because what they will do, everything is managed. Yeah, they would like to have some kind of work at least, and with the containers can be a part of the platform team. So lots of stuff which doesn't make sense for serverless. So basically, we work with serverless. It works for our type of organization. We don't have classical system administrators, and looking at the total cost of ownership of the whole stuff. Yeah, you need to pay people, you need to pay system administrators, and all this stuff. For us, it works, but I totally understand there might be different things. For example, if you're in the regulated environment, then probably you will be pushed toward containers because you can at least partially migrate the business logic to another cloud provider. It's storage, permissions, infrastructure as code is another story, but there may be types of organization in the serverless which creates completely lock-in is not a good solution. But basically, what was my message, and I forgot to say it. If you are productive with the Spring Boot, it doesn't add too much on startup latency comparing to the poor Java. So there's with frameworks you can achieve very good performance. So it's not a stop criteria like it was years before. If you have Springified application, then why not? And that frameworks makes you productive for sure. That was my basic message. Other things, serverless containers, EC2 is a bit broader topic.
Yeah, and usually what I like in such questions to answer, it depends. So here's also, it depends.
I'm not a consultant who earns money by answering all questions with that exact answer.
Yeah.
But it's just needs to be looked. Of course, I still see completely serverless environment more or less as an exception. There are more containerized things, and especially now with that situation in USA, people would like to reduce lock-in. You cannot avoid it, and reduce lock-in, and serverless provides you a full lock-in. So I can totally understand that it's kind of important topic.
Thank you, Vadym. And we have 2 more questions and 4-5 more minutes before next talk. And next question from Andrei Ostapko. What specific challenges have you faced when deploying Spring Boot applications on AWS Lambda, particularly regarding cold starts, memory usage, or integration with other AWS infrastructure?
So there is nothing specific in Spring Boot that prevents you to use something else from AWS services. It's just simple business logic. You can do whatever you would like. It's a bit higher cold starts, of course. A bit higher memory usage because it's in another framework. The classes needs to be loaded, and it's of course then part of the memory. And it's of course then pricing because Lambda is priced by execution time and memory. So it's a bit higher, but a bit. It's just maybe 5% or something like this. But if it makes you more productive, this framework itself, 10, 20% more productive, then it's worth doing. On my opinion, because using poor Java on AWS without frameworks, without these patterns, it just will have other costs, like you will rewrite things instead of reuse things. So this is about the total cost of ownership of application. So there are no particular challenges. You need just to figure out the cold starts is the major one, and whether your application is good for priming. That's the major question, because you will not leave with 7 seconds of the cold starts, especially if it's public facing application. You will not. If it's a synchronous one, it doesn't matter, but otherwise you will kind of suffer.
Thank you for your thoughts on that question. And the last one from Oля Hupal. Yeah.
Okay. Well, it's from GraalVM, so there will be questions.
Regarding using GraalVM native image solution for cold starts, the requirement is to build inside on Amazon Linux 2 container in cross compilation with static or muscle builds. Supported, recommended.
Oh, it looks for me like it's not a question but recommendation. Basically, there is now, I think, Amazon Linux 3 to 2023, where I basically built GraalVM native image. Once again, I didn't explore GraalVM native image in all depth. There are so many parameters. There is this PGO, but it's very difficult on Lambda because you need this, once again, snapshot and then start with that snapshot. It's okay for containers maybe because you can automate it. With Lambda, it's a bit difficult. So there's for sure some GraalVM optimizations. I read even that there will be some dynamic class loading supported in GraalVM next versions, at least, that they explore how to do this. For me, it's magic. But yes, that's my honest opinion. On AWS, they have this native SnapStart, which fits exactly into the Lambda model. But GraalVM is that's then another story. SnapStart is only for Lambda. It's not for containers. It's not for EC2. And there is GraalVM, of course, then basically the only option.
Yeah, thank you, Vadym. Yeah, maybe next time in next event, Oleg can tell more about internals of GraalVM and all these parameters. Yeah. Yeah, that's it from questions section and Q&A. Thanks a lot. Thanks a lot for your talk and for participating as a speaker this year.
Yeah. Thanks for the invite. It's always an honor.
Yeah, hope to see you next time, maybe next year, any other event we will organizing. So yeah.
I would like to be in person if the situation allows. I think we all hope that this will change, which will be then a starting point for other changes. Yeah.
Yeah, and because of that, of course, let's support Armed Forces of Ukraine, and don't forget to donate on any fundraising that you know, and also our fundraising to drones. So please support Ukraine any ways that you can. All right, thank you, Vadym. I'm wishing you a great day, and in 5 minutes we'll have a next talk. So stay tuned.
Yeah, thanks. Bye.